The third angle theorem takes a look at how if two angles are congruent in two triangles, and the third has to be congruent. It kind of reminds me of the congruent supplements theorem. So let's go ahead and take a look at it. So I have two angles in two different triangles here. Angle A is congruent to angle D, and angle B is congruent to angle E. The theorem says since two of these angles are congruent, then the third pair of angles must also be congruent, that pair right there. So we're actually going to prove it. Given that these two angles, A is congruent to D and B is congruent to E, I can prove that C has to be congruent to F. So first of all, my favorite reason, given. Then I can write down the sum of angles here using the triangle sum theorem, and I'm going to do it again for the sum of triangles in the second triangle. Now, what I'm going to do is go ahead and do substitution. Because I know A and D are the same size, and B and E are the same size, I'm going to get rid of angles D and E. So A is going in here, and B is going in there by substitution. Okay, so now I have the measure of angle A plus B, plus that angle is 180. Well, I could, honestly, do the congruent supplement theorem as a shortcut, but I'll go ahead and do the algebra. I'm going to do a subtract, and you might remember this from Algebra 1. Whoops, I skipped one. I'm going to subtract this one right here from line 4 here from line 2. So I show those two being subtracted, and that tells me that the measure of angle C minus the measure of angle F equals 0, and that's by the subtraction property of equality. Well, then I can add measure of angle F to both sides by the addition property of equality, which means if the two measures are the same, then these two angles are congruent by the definition of congruent angles. So we've proven that if two pairs of angles are congruent in two triangles, then the third pair of angles must be congruent. So how are you going to use that? A lot of times it's going to be a little bit more algebraic. We might just say, oh, these two angles are congruent. Then I'm going to tell you angle B is 5x plus 10. Angle E is 7x minus 14, and I want to know how big the angle is. I don't have to know how big angle A, C, D, or F is, because I know these two are congruent, which means they're equal. So I can set their measures equal. Subtract 5x from both sides, and I get 10 equals 2x minus 14. Add 14 to both sides, and I get 24 equals 2x, or x is 12. Substitute back into the measure for angle B, 5 times 12 plus 10, or 60 plus 10, which is 70. So the measure of angle B is 70. So how do we know that the third angle theorem is true? Some further thinking about that. And how do you set up equations for third angle theorems?